everyone, I'm Ms. Hu, your physics teacher. In this video, we're going to solve question 9 in this question paper. Question 9 is from Unit 5, specifically from the topic of radioactive decay. In this video, we are going to do an immediate comparison against the mark scheme to make sure that we have written everything that needs to be written or drawn everything that needs to be drawn to maximize the marks that we can obtain from this question. Question 9. Many household smoke alarms contain a sample of the radioactive isotope americium-241. A. Americium-241 is the isotope of the element americium that has the nucleon number, which is also known as number 241. Number 1. State how the composition of a nucleus of americium-241 differs from that of a nucleus of americium-242. So to answer this question, you need to recall what you do know about the concept of isotopes, as well as what nucleon numbers are. Now, in this question, both of these nuclides are the same element of americium. As you should know by now, the same element has the same number of protons. So the answer cannot involve the discussion of the number of protons. Nucleons, as you should know, is the total number of protons and neutrons in the nucleus. So if both of these nuclides have the same number of protons, what makes them different is the number of neutrons. So that's what you need to mention in your answer. When writing the answer, don't write that both have different number of nucleons, because that's not what the question is asking. Obviously, they have different number of nucleons as already given in the question. The question wants us to talk about the composition of the nucleus. So what's in the nucleus? Protons and neutrons. Don't talk about protons because they're the same. So let's talk about the number of neutrons. So that's what we're going to write in the answer. Be specific. Don't just write, oh, they have different number of neutrons. If you want to get your A or A star, do write what information you're able to clearly derive from the question. In this case, you can see clearly that americium-241 has less neutrons than americium-242. By how many? By 1. So do mention that americium-241 has 1 less neutron than americium-242. So this is an excellent answer because this clearly tells us about the difference within the nuclei of both atoms and which one has less, 241 compared to 242. Let's check against the mark scheme. As written in the mark scheme, americium-241 has 1 neutron fewer in the nucleus. So, ta-da! That's where we got our 1 mark. Next. An atom of a different element has a nucleon number of 241. State 2 differences between the composition of a nucleus of this atom and a nucleus of americium-241. So in this case, this atom now has the exact same number of nucleons. That means the total number of protons and neutrons of this atom is equal to that of americium-241. But here's the thing, it's a different element. So if you remember what you have learned about elements, different elements have different number of protons. So that's why in question 1 just now, we know that americium-241 and americium-242 have the same number of protons because they're the same element. So different elements have different number of protons even if they have the same nucleon number. So that's the first difference that we will write. So both have different number of protons. Because they have different number of protons, they will also have different number of neutrons. How do we know this? Because we know the total is 241. So one would be A plus B equals 241, another would be X plus Y equals 241. And if the numbers of protons are different, obviously the other number, which is the number of neutrons, will also have to be different, even if the total is 241. Logical, right? So that would be the other answer. Both have different number of neutrons. So if you check the mark scheme, There we go. We have different number of protons and neutrons written, and that's how we get the full 2 marks in this question. Now, let's look at the next part. Americium-241 decays to an isotope of neptunium by alpha particle emission. Number 1. Complete the equation for this decay. So in this question, you can see that the equation has been written out for us, but we have to fill in the blanks. So how do we know what numbers to write? Let's start first with what we know. Alpha particles, as you should know by now, is identical to a helium nucleus. So for this alpha, it is 4 to alpha. To fill in the other blanks, it's just a matter of, well, math. So the top numbers should be equal before and after the arrow, while the bottom numbers should be equal before and after the arrow. So the top number is the number of nucleons. You can see we started off 2, 4, 1. 4 have been thrown out for the alpha, and that leaves us with 2, 4, 1 minus 4. That means neptunium has 237 nucleons. So as you can see, 2, 4, 1 before, total of 2, 4, 1 after. And we take the same application for the bottom number, which is the number of protons. So we don't know how much we started with, but we do know we've ended up with 93 for neptunium and 2 for alpha. That means the total here, 93 plus 2, americium started off with 95 protons. So 95 before the arrow, and then 95 total after the arrow. That's how you fill in the blank for radioactive decay. Let's check against the mark scheme. As you can see in the mark scheme, 241.95, so we got this correct. 237.93 in neptunium, we got this correct. And alpha is for 2, so we've got our total of 3 marks. If you didn't get all of them correct, then the examiner will have to check if you scored at least 2 out of these 3 correct to score 2 marks. So either scoring 95 correct or 237 correct, or both 4 and 2 for the alpha correct. Let's move on to number 2. One reason for using an isotope that emits alpha particles in a smoke detector is that alpha particles are more strongly ionizing than beta particles. So explain why alpha particles are more strongly ionizing than beta particles. So if you can recall what you've learned about the differences between alpha and beta, alpha is a lot larger, which makes it easier for it to ionize, but we don't really talk about its size or its mass because those are not the key considerations when it comes to ionization. So ionization is the ability to make other particles become charges. So one of the reasons why alpha is so strongly ionizing is because it contains more charge than the beta particles. It has 2 protons, so a charge of positive 2, as opposed to beta, which is a single electron, negative 1. So having more charges makes it easier for it to attract the electron out from another particle, as opposed to beta trying to repel the electron out from the other particle. So that's one of the factors that we can write. So alpha particles have more charge than beta particles. We can also talk about energy because, again, it's not about the mass, but the ability of the alpha or beta to knock out an electron from another particle. So that means in terms of being able to knock out the electron, it would be about the kinetic energy. So alpha particles have more kinetic energy than beta because it has a much higher mass. So with that greater kinetic energy, it's able to force an electron out of another particle compared to beta. So that's another factor that we can write. So alpha particles have more kinetic energy than beta particles. So these are the 2 main factors as to why alpha is a stronger ionizer than beta. Let's check against the mark scheme. So you can see, yes, the first one is more kinetic energy, so we got that correct. And more charge, which is also what we got correct. So that's how we get the full 2 marks for this question.
So in case you're wondering, how do we tell what factors we actually need to write in this exam paper? One way to tell is to be familiar with the syllabus. So what we're looking at here is one of the pages in the IGCSE Physics paper for the syllabus of 2023 to 2025. So what we're looking at on this page is the list of things we need to know in terms of the nuclear emission. That means what we need to know for the alpha, beta, and gamma emissions. As you can see under the supplement section, explain their relative ionizing effects with reference to kinetic energy and electric charge. That means we need to know the relationship between the strength of the ionizing effect with these two factors. So that's why in the mark scheme, the answer they're looking for in terms of the ionizing effect of alpha compared to beta is based on these two factors, the kinetic energy as well as the electric charge.
Let's move on. For number 3, the isotope of neptunium produced by americium-241 is also radioactive. The decay of this isotope of neptunium produces an isotope of protactinium, which decays by beta emission. Beta particles are more penetrating than alpha particles. The half-life of neptunium is longer than 2 million years. Using this information, explain the advantage of this long half-life for the use and safe disposal of a household smoke alarm. What you need to be aware of is that usually for radioactive material with very long half-lives is that it tends to have a lower activity over the years. A radioactive material with a short half-life tends to release a lot of radioactivity because its radioactivity would drop very quickly in a short period of time. Whereas for radioactive material with a longer half-life, its emission tends to be a little bit more sparse because it's slowly decaying over a long period of time. So with less emissions, that means it's not that it's safer, it's just that there's less activity to worry about. So that's one of the advantages of material with very long half-lives. So that's what we're going to write. Radioactive materials with very long half-lives usually have lower activity over time. So what else do we need to write? So you can see in the question, it's about how the advantage of this long half-life could be for the use and safe disposal of the household smoke alarm. So we know that because it has a lower activity, that means it's safer for use. It is not that dangerous as compared to materials with very high activity. And also, if we were to dispose of it, it's also safer. So let's write that down. Therefore, the smoke detector will not be. So when writing the answer out, try to avoid using the same words that are already in the question. So we're not going to use the word safe because it's already in the question. So find another way to say the same thing. So therefore, the smoke detector will not be dangerous when in use and will also be easy to dispose. So let's have a quick check against the mark scheme. Okay, so lower initial activity or fuel emissions per unit time. So that's what we've said here, lower activity. And it's not dangerous because it's not hazardous. So kind of the same meaning. And also the disposal is easy. So I've given myself 3 ticks here, but if you look at the mark scheme, you can see that for the second statement, it's either or. So writing that smoke detectors are not hazardous or that the disposable is easy will give us 1 mark. And the other mark is, of course, for the lower activity, and that's how we get the 2 marks for this question. And that's how you solve question 9. To find out how to solve the other questions in this question paper, please refer to the playlist in the video description. Happy studying!